Everyone, let's try to solve some Leetcode today. So today we have this binary tree in order traversal problem. And this problem is very easy because it's just a simple implementation of DFS algorithm. So if you know DFS, this problem will be a breeze for you. So basically in this problem, we have been given a root of a binary tree. Note, it's a binary tree, not a binary search tree. Okay. So a binary tree have two nodes. One is left and one is right. But there is no requirement on what values needs to be on the left and on the right node. So what we have to do is we have to return the in order traversal of these nodes. Simple. Okay, so now let us try to understand how to solve this particular problem. So basically we kind of have to apply DFS, that is depth first search, and we have to provide an in order traversal. So depth first search, we understand what it is, right? Basically we will start from a particular node and then we will go in the depth of this node, right? So we can decide whether we want to go in the depth of left nodes first, or we can decide whether we want to go in the right node, right? So that's how basically DFS works. But in the in order traversal, there are some requirements or some rules. So first of all, it is said that you have to go to the left of the tree as deep as you can, and then you have to first print the left node. Okay, so you can print 4, and then you have to print the root, that is 2, and then you have to print the next right node, that is 5 or something. So for example, if I try to traverse in the DFS, first I will be on the 1, then I will go to the 2, okay, but I will not print 2. I will go in the even more depth, that is to the 4 in the left side, right? Now when I'm in the 4, this is null, this is null. Okay, so basically I have two null nodes at 4, but I'm at 4th node, right? So I will go to the null node. So I went to this null node, I see that it's a null, I return to the 4, and then I print the 4. So I will then print the 4. So I'll just write here 4. Okay, then I will go to the right. So null. Okay, so right is also null for 4, so nothing will be printed. Then I will come back to the 4, then I will go to the 2. Correct, I will go to the 2, and then I will have to print or basically write 2, right? Because I have already went through all the left nodes of the 2, so I will have to write 2 here. And then we can actually go to the right subtree of 2. So I went to the right subtree of 2, I found 5, but I cannot print 5 yet. I have to go in the even more depth, right? So I will go to the left node because left is present, and the left is where we go first whenever we are at any node. So I will go to the left node, I found 7. Then again the same situation, null and then null. Both left and right nodes are null. So I will end up going to the left node. Once null, I will see, okay, it's a null node. I will return without printing anything. I will come back here. Then I will simply print the node. So that means I will write 7 here. And then I will basically go to the right node. It is also null. So I will come back without printing it. And then I will go back because I have already printed the 7, correct? I will go back to the 5. Now once I go back to the 5 from the left subtree, I will simply print the 5. So 5 will come here, right? And then I will go to the right subtree of the 5. So it is null currently. Right subtree is null. So nothing will happen. I will go back to the 5, correct? Nothing will be printed. And then I will go back to the 2, right? Now we have already printed 2 earlier. So we will not be printing it again. And now I will go to the 1, correct? Now for this particular one, we have already covered all of its children nodes, correct? So it means its entire left subtree we have already printed here. So now what we will do is we will print 1 here, right? So 1 will be written here, or 1 will be appended to our list. Now we will go to the right subtree of 1. So now once we go to the right subtree, we encounter 3. Now on this node, again, we will first have to go to the left of this node, and then only we can go to the right. So on 3, I will go to the left without printing 3. I'm not printing right now. I will go to the depth of it to the left, and I see 6. Again, we have null left and null right nodes. So I will go to the null first, left, right, and then I will come back. I will print the 6 now. So 6 is here. Then I will simply go to the right of the 6. I see null. I will simply come back without printing anything. And then all the subtrees, that is left and right, are gone or have been processed for 6. I will go to the 3 now. Now since I have processed the left subtree of 3, I will now simply print the 3. Correct? So the next will be 3. 3 will be printed, and then I can actually go to the right subtree of 3 here, and this is currently null, so we cannot print the null. So I will go back here. Okay, we have printed the 3, and then I will go back here. We have already printed 1 here, so I don't need to print anything. We have printed all the things. So basically our answer has been done, right? Our answer is complete at this point. So this is the in order traversal. First, what we did is we went to the left, correct? We went to the left like this, from 1 to left 2, correct? But we did not print anything. Then from 2 to 4, this is where we went. Now, once we reached the 4, we realize that there are no left or right subtrees for 4. They are both null, correct? So we cannot print null. So we simply printed 4 here first, correct? Then we went back to 2, and then we printed the 2. Okay, so we will first print the left. Okay, then we will print the current root. Okay, and then we will print the right subtree nodes, correct? So we first went to the left, so we printed 4, then we went to the root again 2, and then we printed the 2, then we went to the right subtree, right? And we encountered 5 here, but we did not print it here, right? Because we have to go to the depth of it. So from 5, first we went to the left subtree. Okay. So from each node, first we have to go to the left subtree. Okay. And similarly here, 7 have no left or right subtrees. Both of them are null. So I simply printed 7. So 7 is now here, correct? And now we can actually go back to the 5. Now we went to the 5. We have already completely printed or processed the left subtree of 5. So we can print 5 now. And that's what we did here. We have printed 5. We tried to go to the right subtree, but it's null. It is null. So we cannot print anything, correct? So we went back to the 5. And from 5, we went back to the 2, correct? From 2, and then from 2, because we have already printed the true, right? We have already processed the root node 2. We went to the 1 now. So we have processed the left subtree of 1. Now we can actually print or process the root node 1. So I printed it here in the list, right? Now I can go to the right subtree. I will go to this subtree. Okay, for 1, I went to 3, but we cannot print 3 right now because 3 is not the last node for this subtree. So I will go to the next node for 3, that is the left node of 3, correct? So I see the 6, I will print the 6 because 6 also have just null node for right and left trees. So 6 will be printed here. Okay, once the 6 is done, I will go back to the 3, I will print this current root node 3. So 3 will be printed, right? Then I will go to the right subtree. It is null. So since it is null, I cannot print anything. I will simply go back to the 3. And then from 3, I will go back to the 1 because 3 is already printed, right? We have already processed the root node here, correct? Now I went to the 1. I realized that the right subtree is also done. So now our in order traversal is complete. Now the problem that people face is basically in recursion. Okay. So usually the function is written something like this. We will have a DFS, right? It's a DFS function. We will pass a node, or maybe just node, I would say. And then that's it. Usually this is basically the way to do this in Python. Okay. So then you will see a base condition. If node double is equals to null or none, basically in Python null and none are basically kind of the same, so you can think of them analogically, and then I will simply return, right, without printing anything. Now understand that this condition will only be true after reaching the leaf nodes. Okay, so basically once I reach the leaf nodes, okay, if I try to go to the left node and pass the left node to this function, okay, so left is null or none basically. Okay, it's a, they doesn't exist, right? So this is where at this point this particular condition will be true. So we will simply return because we cannot print the none, right? So we will return here at this point. Now after this if condition, basically you will have this. Okay, you will again call the DFS in the recursion, and you will pass a node.left. After this you will write here something like this, list dot append current nodes value. So node dot val. Okay, so current nodes value you have appended, and then again you will write something like dfs node dot left. Sorry, not left, it is right, because now we are dealing with right subtree. Okay, so how does particular function works, right? So basically what will happen is that you will call this on the root node. Okay, so first this will be a root node, right? So first the node will be 1, because at this point the root node is 1 for us, right? Now the node is 1 and node is not null. So this condition will be false for 1. Okay, so then we will again go into the depth of 1. So node dot left means the left node of 1, that is 2. So we are first of all basically trying to process all the left nodes of 1, right? So we will pass 2 here on this position. Okay, simple. We will pass 2 here. Now node.left is 2, and remember at this point there will be a call stack. Okay, so once this line hits, okay, a new stack, basically this call will be placed on an internal stack by operating system. So this will be placed on a operating system. Okay, suppose dfs 2. So this was the dfs 1. Okay, then now this is on dfs 2, on node number 2. Okay, similarly for 2 also we will first go inside of this function. On the if statement we will check, okay, 2 is not none, so we will now again go back here on the dfs. So we will place the left node of 2. So currently the left node for 2 is 4. So now this will again hit this dfs node dot left, and we will again have a new call stack for this dfs, right, for 4, for root node 4. Okay, so now we have 4 here. Now currently we have 4, that is leaf node. Now again the same logic will happen. Okay, so we will check if the 4 is none or not. Okay, and it is not none, so we will now place or basically put node dot left. Okay, so the left node of 4 is none, or null or none. Okay, in python it is none, so this python is none. Okay, so now this is none, correct? And it means first of all there will be a call stack for this. So dfs none. So none will be passed in the dfs, and then in this particular call stack, okay, in the topmost call stack call, okay, this condition will be true, correct? This condition will be true. So what will happen is that we will return. So we once we return from here, okay, this particular call will be cancelled, or basically this particular call will be returned. So this topmost call is now does not exist in the call stack. It just finished, correct? Now we are back on the dfs 4. So once we are back on the dfs 4, so in this particular call we were on this particular line, correct? Now this is done, this line is done, the function call for this was done, we have seen. And now we will go to this line particularly. Now the 4, the value 4 will be appended to our list. At this point the 4 will be appended to our list. Okay, and then we will now go to the right subtree of 4. Now we see that the right subtree of 4 is also none. Basically for the right subtree there will be another dfs call here. Okay, so the dfs will be something like this, dfs again none. Okay, and the same thing will happen, we will hit this particular line, okay, this particular condition, and then we will cancel the call, not cancel, actually return the call. So this will also be gone, and then we have processed both left and right subtree for 4, correct? For 4 we have processed it. Now what will happen is that after this line, this particular call, okay, this particular call will return automatically. It will return automatically. So dfs of 4 is now returning. Now we are reaching the dfs of 2 on at this point. Okay, so on dfs of 2 what will happen is that even on dfs of 2 we will again be stuck on this particular line, but this is now completed. So now we will go to the next line, this particular line, correct, on appending the nodes value, and now we will append 2 here, simple. And then we will go to this line and we will actually try to explore the right subtree of 2, right? So now we will go to the right subtree of 2, that is dfs of 5. So now the call stack will again have another call, that is dfs of 5, something like dfs of 5. Okay, now for the 5 also we will again go for the 7, that is we will again hit this line, this particular line, correct? So this line will be hit, and then we will again have the seventh, or basically the DFS of 7. Okay, DFS of 7. Then 7 again have a null nodes. Okay, so first we will try to go for DFS of none for left node. DFS of none for left node, we will see that it will simply return. So it will be cancelled or basically return early, right? Because of this particular condition, because of this one. Okay. Now, once that happens, the DFS of 7 again resumes or continues from this particular line. And then we will go to this line, correct? And then we will simply append 7. And then we will go to the right subtree of 7, right? So right subtree of 7 is also none, correct? Because there is nothing there. So we will simply again have a DFS of none, DFS of none on the call stack, correct? And then it will also return, it will simply return, it will return, okay, and it will come back to the 7, right? It will come back to the 7 at this position, it will come back. And then after this, there are no code, so it will simply return. So the DFS of 7 will also simply return because it has been processed. Okay, now we are back on the DFS call of 5. So the DFS call of 5 here, okay, in this DFS call, we are still stuck on this particular line. So we will move and we will go to the append line. We will append the 5, and then we to go to the DFS of right node. So the right node of 5 is again null. So I will not make a new call, but understand that there will be a new DFS of none, which will simply return early, okay, in the call stack. And then we will go to the 2, and in the similar way we will reach back to the 1. Okay, because for 2 we have been stuck here, so once the right node or right subtree of 2 is done, so the DFS of 2 will also be cancelled or basically returned, and then we will go back to the DFS of 1. So the entire left subtree for DFS of 1 is now done, correct? Now we will move to this one particularly, and then we will simply add 1 here, okay, in our list. And similarly, we will then again proceed to process all the right subtree of 1. Okay. And in the same way, we will have DFS of calls, okay, for 3, for 6, for all the levels basically. And then eventually we will have our in order traversal like this. So this will eventually become our in order traversal 4, 2, 7, 5, 1, 6, and 3. Simple as that. That's how in order traversal really works. Now here's the Python code for this. It's a very simple code. So I have a global variable res. It will basically store our result. Then I have defined a function in the in order traversal function itself. So in the DFS, I am basically taking a node. Okay, I'm not saying that I'm taking root. I'm taking any node. It's an easy way to understand the DFS or basically call stack. So I'm taking any node, and then I'm checking if that node is none or null. So for Python, it is going to be none. There is no null in Python. So we will return if it is none, and then we will check. Okay, if it's not none, then first we will check it's in left subtree. Then we will append the value of this particular node to the rest, correct, as we have seen, and then we will check its right subtree, correct. Now the function ends here, and now we are simply calling this function here with the root. So we are passing this root here in the DFS, and this root will simply run and then populate the res, and then we will simply go ahead and return this res. Now all we have to do is run this thing and see what happens. So as you can see that it's just good enough. I would say I mean, you cannot really trust the Leetcode thing because it says 0 millisecond. I mean, there is nothing that can work in 0 millisecond. That's kind of crazy, but I would say it's a good enough solution. There is no extra space. There is nothing. I would say just a call stack of extra space. And in terms of time complexity, if we analyze it, I would say space complexity is order of n because we are using the space for a call stack, and the time complexity is going to be order of n because we will actually be traversing through all the nodes. So yeah, both are order of n right now. And even if you try to create an iterative solution for this, that will again need a stack. It is just that you will have to maintain that stack by yourself manually. Currently, the recursion is handling that stack for us, but if you use iterative, you will have to maintain it by yourself. So yeah, if you have a question that you would like me to target specifically, then just let me know in the comments. Bye.